Hi everybody, this is Mr. Short. Today we're going to set up our periodic table with three important pieces of information: main group number, charge above each of the 8 main groups, and period numbers. We're also going to take a look at this sheet over here and confirm some of the stuff with these electron configurations and Bohr models that we write on our periodic table. So let's start with the main group number. Remember, the main group number, which is 1, 2, skip a few, 3, 4, 5, 6, 7, 8, the main group number tells you the number of valence electrons in the neutral atom. And remember, valence electrons are the electrons in the outermost energy level. So for example, if you're talking about an element in main group 1, every element in main group 1 would have 1 valence electron, just like every element in main group 8, from neon down to radon, would all have 8 valence electrons, giving them a stable octet of 8 valence electrons. Let's confirm that by taking a look at this sheet over here at potassium and phosphorus. So I can easily count in the Bohr atomic model that potassium has 1 valence electron. That is 1 electron on its outermost energy level, and we would say it's a 4s1 valence electron. Let's confirm that by looking at the periodic table that potassium has 1 valence electron. Potassium is right here. It's in main group 1, telling us that it's got 1 valence electron. Likewise, we've got phosphorus. Phosphorus has 1, 2, 3, 4, 5 valence electrons, 5 electrons in its outermost energy level. And we would say that those valence electrons are 3s2 and 3p3 valence electrons. So these 2 plus these 3 give you 5 valence electrons in phosphorus. And phosphorus, you can see, is in main group 5, meaning everything in main group 5 has 5 valence electrons. Okay, let's take a look at charges here. Remember, in red, we've got the charges that elements in the 8 main groups take when they turn into ions. And the saying here is +1, +2, skip a few, +3, plus or minus 4, -3, -2, -1, 0. The reason they take these charges is because when atoms turn into ions, they gain or lose the fewest number of valence electrons possible to have a stable octet of 8 valence electrons. So for example, since phosphorus starts out with 5 valence electrons and it wants 8 valence electrons, it's going to gain 3 electrons to take a -3 charge, giving it a stable octet. And we can confirm that by taking a look down here. Remember, it's got 5 valence electrons. It wants to gain 3 to take a -3 charge, now giving it 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So phosphorus likes to take a -3 charge because it's in main group 5, as does everything else in main group 5. Likewise, we see that potassium likes to take a +1 charge. When potassium turns into potassium ion, it takes a +1 charge, and it's going to lose this 1 valence electron, giving it a stable octet of 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so remember, everything in main group 1 would like to lose 1 valence electron, giving it a stable octet of 8 valence electrons. And then the very last thing is the period number. So remember, the period number tells you the number of energy levels in the Bohr atomic model. The period numbers are down the side, and they are the horizontal rows. They go period 1, 2, 3, 4, 5, 6, 7. So hydrogen and helium would be the only period 1 elements, just like the period 2 elements would be all of these right here. Okay, so remember, the period number tells you the number of energy levels in the Bohr atomic model. We have potassium right here, and we can clearly see that it's got 1, 2, 3, 4 rings. So it must be in period 4, and here's potassium in period 4. Likewise, we would predict that phosphorus, which is in period 3, would have 3 energy levels, 3 rings in its Bohr atomic model. And here's neutral phosphorus with 1, 2, 3 rings in its Bohr atomic model. Okay, hope you guys understand why we set the periodic table up like this. If you ever lose your periodic table, you're going to want to go back to this video right here and make sure that you set up your new periodic table this way. All right, thanks a lot, guys, and see you soon.